be more work. So let's say this would be 2 to the power of what?
2 to the power of 2 to the x.
Yeah, and can you simplify that?
On the right hand side, it would be 2 to the 2 to the 2.
Well, 4 is 2 squared.
Oh, so just to the 8.
Okay, and can you simplify 2 to the 2 to the 8?
2 to the 16.
Yeah.
Okay, times 2 to the 8 is...
How about this one?
2 to the 2x.
Yeah.
Oh, and then you eliminate the base. So you eliminate the 2, so you get 2x equals 16 times 8.
Well, how do you multiply indices?
You add them together.
Yes.
So 2x equals 16 plus 8, which is 24.
And
so x is 12.
That's it. And so in general, that's how you do those. You bring them down to a common base.
Yeah. Just check it. So here we had 4 to the 8 times 3 to the 8 times 2 to the 8.
Yeah.
And since 4 and 2 are both sort of factors of each other,
yeah,
or 2 is a factor of 8, that's why we can't get 4 to the x straight away. So that's why we can't determine x right away.
Yeah, so I mean, well, we shouldn't really have even been able to determine the 3. It's just because 3 doesn't have a common factor with 4 and 2.
Yeah.
And so I knew that part is definitely 8. And
okay.
so it's like we divided both sides by 3 to the 8. So you were left with just the 4x is equal to. And the thing is, x isn't 8 because we still have a 2 to the 8 as well.
Mm-hmm.
And so you have to go through the process of bringing them all down to a common thing and then solving it from there.
Yeah. Okay.
So the good part was getting rid of this 3. It's equal to 1. Oh, okay. Let's try this one. Or is that applied enough for you? Well, it's difficult enough, I suppose.
Yeah, we'll do it, so.
Alright.
Okay.
So we didn't do much indices.
Give me 2x plus y equals 1. And would we make it a simultaneous equation?
So I think it's going to be a simultaneous equation.
Yeah. So we have to make sure that it is equal to 100. So the left part is equal to 100. Yeah.
I wouldn't do it that way.
Divide is on the right.
I still wouldn't. 10 to the power of what gives you 100?
10 to the 10.
No.
To 10 squared even.
Yeah. So 10 squared is 100.
Yep.
So what do you know about 3x minus y?
It has to equal 2.
Can you do something similar for the other one?
So the other one has to equal 0, so x plus y equals 0.
Yeah.
Equals 0. Okay. So then we do...
I'm sure your fancy calculator can do this somehow.
But math, if you just do it on paper, would you make it 2x plus y equals 2? I know it doesn't work.
They're simultaneous, so
Okay.
It's under equation.
I get a half and minus a half.
X is a half, y is minus a half. There you go.
How would we do it just on paper?
You could add both of them together.
Add them together.
What would you get?
So 4x equals 2.
And so x equals?
X equals a half.
Yeah. And
then you would substitute it in. Oh, okay.
And so y must be minus a half
minus a half to get 0. Okay.
Line. Dot product. This is it.
Yeah.
Okay, so this one, the angles and the scalar products, they call a scalar product. So you either put them head to head or tail to tail when you're finding the angle between them. Okay, what is the angle between the two vectors for each one?
So for A, it's 90 degrees.
Yeah.
Straight off the bat. For B, it would be 45.
Yeah.
And for C, it would be from tail to tail. So that would be 135 degrees.
Yeah. That's it. Let's see. So this is the thing. How would you do part B?
So what does the line, or what do the lines mean?
Magnitude.
So, okay, so the magnitude. So we would use Pythagoras' theorem, and we would do square root of 1 squared plus square root of 8 squared equals the magnitude. And that would get square root of 65.
Okay.
Which is 8.1, pretty much.
I'll just use root 65.
Okay.
And B?
For B, it would be the square root of 4 squared plus the square root of 3 squared, which equals 5.
Okay. What is the magnitude of B minus A?
So on a graph, how could that be drawn?
So B minus A is the same as minus B plus A.
So minus B plus.
So that's, if you're starting here, that's minus A.
Yeah.
And then plus B. And so it's the magnitude of that red line.
So if you were to do B minus A, you would go up along B and then do a negative A?
Yeah. And so the way I'd visualize it, the way this is drawn, is it's the same as minus A plus B.
So it doesn't really matter the way or which way around it goes.
Yeah, like 3 minus 2 is the same as minus 2 plus 3. So B minus A is the same as minus A plus B.
Yeah.
And yeah.
Okay, so would you just find the differences in magnitude, or would you go say?
So B minus A is this red line.
Yeah. Could you use the magnitude you found already?
I doubt it. I
No.
don't think
Okay.
so.
So you would do the square root.
No. You could do b. You could do these two up here. You could do b minus a and do the magnitude of your answer. That's one way to do it. Or just use a diagram. If you if you didn't have a diagram, you could just do b minus a and then do the Pythagoras of that.
So with with a and b, you do 4 plus 1, and then find y, and then do both of them like that.
Yeah.
Okay. So on the graph, it's square root of 5 squared plus square root of 4 squared.
Yeah.
Which is square root of 41.
Okay. So that's root 41.
Mm-hmm.
B was 5. And that was root 65. You have to use the cosine rule to find theta, the angle theta.
So a squared equals b squared plus c squared minus 2bc equals a.
Yeah.
Yeah. C equals a. So we want to find cos a. So it's a squared minus b squared minus c squared plus or over 2bc?
Over minus 2bc.
Over minus 2bc. Yeah. And a in this instance, it would be square root of 41.
Yeah.
Right. Okay. Just making sure. So the square root of 41 all squared. Oh, this is going to take a little while. Minus b squared. 5 squared. Minus square root of 65 squared. Over minus 2 times 5 times square root of 65. I get 0.6, then we need to inverse cos it.
Mm-hmm.
Is it inverse cos or just? Yeah, inverse cos.
Mm-hmm.
Inverse cos the answer, which gets 52.57 degrees.
52.57 degrees. There we go.
Yeah.
Yep. 61.3.
Oh.
Hang on. 61.3. Root 41. The other was root 50. This one should have been root 50. The
root 50.
A?
Did I do it wrong?
Yeah, it should be root 50. Yeah.
1 squared plus 7 squared. Oh, I must have done 8 squared. 5 root 2.
Yeah, 5 root 2 or root 50, same thing. Yeah. Okay. So that's alright. And you have the idea.
Yeah.
Any questions there?
No?
Okay. So that's 50, whatever. That was that 50. Okay, so you can put vectors. So instead of finding the magnitude and then doing Pythagoras to find the magnitude and then putting it into the cosine rule, you can just put the vectors straight in. And so if you put the vectors straight in, what you get is, like, if you go through the whole thing, the magnitude of c squared equals magnitude of a squared plus magnitude of b squared minus 2 magnitude cos theta.
So that's essentially the same thing as the cos rule.
So that's what we did.
Yeah.
And if you compare this with what you get when you put in all of the vectors without finding the magnitude first, you'll notice that AB cos theta is equal to this. A1 A1 times B1, A2 times B2, A3 times B3. And so what you get is cos theta is equal to the first. So you can see there's two vectors here.
Why does the vector have 3 numbers?
Because they're using 3D vectors. Is that right?
Aha.
Yeah.
Okay, I haven't come across 3D vectors yet.
So they're using 3D vectors. So our one would just have, we would just use 2 if you were using your one. But
yeah. No, we'll carry on like this.
Okay. So, yes. So let's just use the dot product method. So we'll just do G4. What is A1 times B1? That one.
So that would be 3 times 3, so 9.
Yeah. Go on.
So 9 plus minus 10, so 2 times minus 5, plus 1 times minus 4.
Yeah.
And then so that'd be 9 minus 10 minus 4. So that would be minus 5.
Yep. Any idea how you get the magnitude of A if it's 3D?
Not sure.
It's Pythagoras, but with 3 of them. So 3 squared plus 2 squared plus 1 squared, and square root your answer.
Okay. Should I figure it out?
Yeah, go on, yeah.
That's 2 squared plus 1 squared. Square root of 14.
Okay. And same thing for the other one?
So square root of 3 squared plus minus 5 squared plus minus 4 squared. I need to put the minuses in brackets. Uh, 5 square root 2.
So that's the same as root 50.
Yeah.
And so what our dot product formula does for us is cos theta is equal to the minus 5 over root 14, 5 root 2. And then you inverse cos to get theta. And so I suppose what we could do, so if I go back to this one, so if we had used it for this one, it would be for the sides A and B, so the two sides and the angle between, and you would do the dot product over the magnitudes.
Yeah.
Would give you that one. Show that the dot product is 5. Okay, so how do we do G5?
Okay, so we just take the ij and k. So we do 2 times 1, so plus 1 times minus 1, plus 4 times 1 equals 2 plus.
They told me it's going to be 5.
Oh, okay. So that's what the dot product shows us. Oh, okay.
Yeah. Okay. How about G6?
6 points A and B lie on a circle. A and B is 35 degrees. Find the correct 2 decimal numbers. So we know. We
has a radius of 5.
Yeah. You know that angle is
35 degrees.
Yeah. So do we know cos 35 equals?
Find OA dot OB. The dot product. So what is the vector O to A?
O to A is...
yeah. So we could, you could pick whatever you wanted for that one.
What do you mean?
So what coordinate would you give to A?
So it would be 5, 0.
Yeah. So we could say A is 5, 0.
Mm-hmm.
And so how would we get the coordinates for B then?
So we know that the angle is 35. Mm-hmm. So we can use the cos... No. We can use the cosine rule.
So we just need its height and its... So that's 35. Is there some way to find out how high up it is? Using like Sokotoa or something?
Yeah, that's what I was thinking. Oh, so you can use sine 35?
Yeah.
Yeah, so 5 sine 35.
Yeah, it's just 5 sine 35 is its height. And
that is 2.7.
I'm just going to write
2.86.
I'm just going to write 5 sine 35.
Okay.
And it's x.
So 5 cos 35.
Yeah. And you have to
4.1. Yeah.
And you have to find the dot product for those two.
So you would do 5 times 5 cos 35.
Yeah.
Plus 0.
Yeah.
Okay.
And whatever that is. Let's see. What can you deduce? Oh, okay. Let's do this one. G7A.
G7A. Evaluate A. Dot B. So you would just do 6 plus 5 plus minus 11.
Yeah. What do you get for that?
6 plus 5 plus minus 11. 0.
Yeah. And so what can you deduce about cos theta from that?
Is it 90 degrees?
Correct. Yeah.
Yeah.
What does this tell you about the vectors A and B?
They are perpendicular to one another.
Correct. And so that's quite common for these types of questions.
Okay.
That's the perpendicular one. Show that these two are perpendicular.
So we would do A dot B.
Yeah.
So 8 minus 3 minus 5. So that's 0 again.
Yeah.
And then wait, I'm just thinking, how does cos come into this again?
The formula.
So A dot B equals magnitude B magnitude A.
Well, no, that's not a good formula. Why did I use that? I should have used when you cos theta equals A dot B over magnitude of A magnitude of B. So this is A dot B.
Yeah.
And so 0 over magnitude A magnitude B is
equal
still
to 0.
Cos theta.
Yeah.
And so, go on.
So it's still 0?
Yeah. So the only way is that it doesn't matter what's on the bottom.
Yeah.
And so theta is 90 degrees, therefore.
The lines are perpendicular.
Yeah.
And to find the magnitudes, we would do Pythagoras.
Yes.
Okay.
Okay, find the angle between these two vectors.
So to find the angle. Okay, so 2. So we're doing A dot B. So that's 2 minus 18 minus 3. So that's just minus 19.
Okay.
So that's minus 19 over the square root of 2 squared plus 6 squared minus 1 squared times square root of 1 minus 3 squared plus 3 squared.
And because anything minus squared becomes plus, I just write them all as plus. It won't make any difference.
Oh yeah, okay.
Over 36 that's root 41. And the other is 9, 18, 19. Okay. That's equal to cos theta.
Yep. Should I figure out?
You just inverse cos it. Yeah, go on.
Yeah.
Might as well.
Yeah. 41. So 132.9 degrees.
9 degrees. Yeah, 132.9. The angle between two straight lines. Okay. This, right. Sure. What is this? Okay, let's try this one.
Okay.
And is 3D 3D vectors in your thing? Do you know?
I think we'll be coming across them later on.
Okay.
I can have a look.
Okay.
Oh, this is just, I only have the year 1 in the AS book with me at the moment.
And what is your other thing, Dad? It's further maths, is it?
Yeah. Yeah, it's further maths.
Okay. Go on, we'll try this.
Okay. So, requirements A, F, G, and H. Find the acute angle between what does acute mean again?
Less than 90. Basically just find the angle between them.
So H and F is on a different plane to A and G.
Right.
So yeah. So A to G. Oh, is it A? Yeah.
And H to F.
Yeah.
Right.
Okay. Would we find the, so we would look at it from, so say we were looking at it from above and we gave the intersect points M.
Right.
And then we take it back to this view and then we do G to M and we'd find the angle of depreciation between GM and GA. Would that work?
I don't know. I would just find the vector A to G.
A to G. Okay. So that's 4, 3, 2.
Yeah. And the other one?
And the other one is 4 minus 3 and 0.
Okay. and then I'd find the angle between them.
Oh, okay. I see. Okay, so the angle between them, so we do A dot B. Okay, so A dot. So 4 times 4 is 16, minus 9, and 0.
Okay.
So that's 7. Yeah, so 7 over and that's all over the square root of 4 squared plus 3 squared plus 2 squared multiplied by the square root of 4 squared minus 3 squared and 0 squared. And I get 75 degrees.
Square. Yeah, 74.9, something like that.
Yeah.
Okay, so let's hope this is right. Yeah, 74.9.
So if we just go back,
Yeah.
where or how would we visualize this angle?
So let me just go back because they're so connected. So basically, if you've got two vectors, and they don't cross over, the angle between them is just, if you were to imagine that they do cross over, if you were just to extend both lines. And so with this one here, if they don't cross over, you can just imagine that they kind of just put them together so they do cross over.
Right.
So they extend them either lengthwise or make their own plane with each other.
Right. So if we go to the one that we saw.
Yeah. Yeah.
So we would just imagine that the H is brought onto the G.
Yeah, so you either bring the red one up or the blue one down so that they do cross over.
Okay. And how would we know which angle to measure?
So they said the acute angle. So if we just go back for a second. So if they wanted the obtuse angle, it would be 180 minus 74.9.
Oh, we'd look at it like this.
Yeah.
Like that. Oh, okay. I see.
Yeah.
I see. So basically, if we were just to look at the box top on, it would give us that view. Because we'd eliminate the Z component.
Say it again, sorry?
So if we just looked at the box H, E, F, G.
Yeah, exactly.
Yeah, okay.
I'll just see what the rest of them look like. Can you show that these lines are perpendicular? You haven't done vector lines, have you? Equation of a vector line?
No.
Okay, so it's basically, just in case you do, it's basically y equals mx plus c. And so this is the m, this is the m, and you do the dot product of those two and see if you get 0. But I don't think that you need to do it applied to these lines. So you can see there, that's the m and that's the m, because that's the thing being multiplied by something.
That's so the is m the whole bracket?
Yeah, it's those three things. And the dot product of those would be 0.
How would we know which ones are X and C?
So where's it gone? So I don't know if you need this, but the one that's not being multiplied by anything is C, And in this case, lambda is used as x.
Yeah.
So
you can, lambda's x and c is...
You can imagine if that was y equals c plus xm. It's like they've just put it into that format.
So the 2i minus j plus 6k, that is the c value.
Yeah, that's c, because it's not being multiplied by anything.
Yeah. Okay.
Just in case you need it. But that's dot product anyway.
Mm-hmm.
How was that for you?
That was good, insightful.
Yeah.
Actually, yeah. Something new.
And you've got the main stuff of it as well, because it's show that they're perpendicular is doing it equal to 0.
Mm-hmm.
So anything in particular you want to do next time?
As of now, I can't think of anything, but I will let you know as soon as I can.
Okay. Any questions for me in general?
No. If these could be sent to me.
Yeah, well, yeah.
Okay.
Well done. Gregoire, you did great. I look forward to talking again next week.
Thank you.
All right.
Bye.
Have a good week. Goodbye.